Okay, hi everybody. My name is Esther. I'm here to present my assignment on electromagnetic spectrum. So this assignment covers what electromagnetic spectrum is. What is electromagnetic spectrum? They are a range of frequency or wavelength of an electromagnetic radiation. According to ESCA, the term electromagnetic spectrum is the term that scientists use to explain or describe the entire range of light that exists. From radio waves to gamma rays, most of the light in the universe are in fact invisible to us. For example, although we can see the sun, we cannot see the effect or charges the sun emits through infrared radiation or ultraviolet waves. These effects can only be determined by identifying the property or the property of that wave. There are seven types of electromagnetic waves. They include radio waves, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. And these properties are, they are lined up from the length of their wavelength to 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 the length of their actually to how long their wavelength is and how short and how high their frequency, their energy is. So we can see from radio waves has the longest wavelength and gamma rays has the shortest wavelength. We can also see in this image that radio waves has the lowest energy and gamma rays has the highest energy. Okay, so these waves all have the same principle. Shorter wavelength equals higher energy and higher frequencies, whilst longer wavelengths. Oh my God, I'm sorry. So shorter wavelength has higher energy and higher frequency. That is gamma rays. For example, it has the shorter wavelength and it has higher energy and higher frequency, whilst longer wavelength has lower energy and lower frequency. Okay, so what are the properties of electromagnetic waves? They all travel with the speed of light in a vacuum. The speed of light is about 300 million meter per second. That is fast. They are in order of increasing frequency and energy and then decreasing wavelength in the electromagnetic spectrum. Like I just said, they are transverse waves and they transfer energy. This picture just gives us a quick example of what each of the waves does or some of the types of what they stand for. For example, the radio waves, they are used uh, to broadcast radio and television, as the name implies, radio waves. Microwaves is used in cooking, like we know radar, telephone, and other signals. Infrared transmits heat from sun, fires, radiators. Visible light makes things visible, makes things able to be seen by the human eye. Ultraviolet absorbed by the skin, used in fluorescent bulbs. X-rays used to view inside of the bodies and objects. Gamma rays is used in medicine, in the killing of cancer cells. So we're going now to microwaves. What are microwaves? Microwaves are shorter than radio waves. They are the next in line after making radio waves. So they're shorter than radio waves in length, in wavelength, and ranges between 1 meter to 1 millimeter. So they conduct electromagnetic charges in a straight line. So they don't appreciate interference. They are reflected by metals, which are good conductors of electricity. They hit materials if they can make atoms or molecules in the material to vibrate. They pass through glass and plastics. They pass through the atmosphere, so which means they are harmless. Excuse me. Now look at the one we know, microwaves helps to heat up our food. How does it heat up this food? By penetrating into the water. Okay, by when the microwave is able to make the water in the food to vibrate, It helps this water now passes the hot, the heat energy to the food, which now helps food to warm up. So these are some of the appliances that are incorporated into the microwave to help it radiate that microwave radiation onto our food to help us eat it hot. So now what we are looking at, infrared radiation. Infrared comes after the microwave and before the visible light. The word infra is a Latin word which means just below. Infrared then means just below red. This type of radiation is also known as heat radiation, which shows the temperature or heat coming from a particular point or surface. Infrared radiation ranges between 1 millimeter to 750 nanometer in the electromagnetic spectrum, and they can be seen on our skin, like our face, our hand, our body, toasters or boilers. My laptop as well is releasing my, infrared radiation because it's heating up. And heaters, remote control, or even the temperature of a house. The infrared radiation is not visible to us, but some animals like snakes, they can see through infrared radiation, and this helps them to hunt their prey. Equipment such as thermometers are very good in checking people's body temperature, which helps the doctor to now, or the medical professional, to have, to start thinking, okay, start making good judgments. For example, if someone's temperature is hitting 38 degrees, 39, 40, you're thinking, okay, why is this person hot? Maybe they have infection, they have trying to have sepsis, or something is wrong somewhere. If the person is hypothermic, you're thinking, okay, I need to keep this person warm so that the blood can flow properly. Infrared lights are also used for short distance communication. For example, remote control. So, when you're in front of your TV watching TV, you have to be within distance to be able to press the numbers, because if anything is obstructing the remote from the TV, it wouldn't work properly. So that's why we kind of raise our hand or sometimes move the position to make sure that we are within range, so that so that there's no obstruction for the infrared communication between our remote and the TV. Okay, so here we have a picture of a boy and his football. Oh, so I'm sorry. I'm sorry. You don't have to move. So we have a picture of the boy playing football. You can see from the picture, the boy is oozing infrared radiation as well as the football. You can see they have both worked hard. Yeah, so they're all hot. The football has done well. The boy as well has really played well. So that's an example of electromagnetic infrared radiation. Okay, now we are looking at the sun. Like I mentioned earlier, we can see the sun. We're going to look at UV light as compared to visible light, okay? The UV light, which is ultraviolet light compared to visible light. We see the sun, we can see it. Now the sun is out, amazing. But there are also other things that comes out from the sun, like the infrared, the heat coming from the sun, keeping us warm, keeping the temperature of the neb of our environment warm. And then there is ultraviolet wave that comes from the sun as well, which most people relate to tan. Okay, that it tans the body, and people have to put a sun cream on and things like that to protect their body from the ultraviolet wave. Okay, so the visible light we see with the sun out, we can see colors. With the light out, we can see colors. We can see yellow, green. We can see the sand is green. The sand is orange. We can see the sun is yellow, whatever color it is. We can see things. We can see the trees are green from the light because the light is on. The sun is out, or we can see the day. That is the visible light we see. Now the UV light has three categories. The UVA is not harsh. It's relatively okay, but UVB and UVC, they are the harmful part of the ultraviolet wave. Let's look at it quickly. Let's look at the visible light and the ultraviolet light quickly. What is visible light? Visible light, this is the type of electromagnetic wave that is visible to the human eye. It ranges from the colors red to purple, formerly known as Roy wave. Red, orange, the red, orange, yellow, green, blue, indigo, violet. Visible light is found between infrared, after infrared, and before ultraviolet wave. Okay, some of the visible light is sunlight, fire, electric bulb, hot objects like cookers or lamps that are causing some fire out. Okay, some visible light out. Excuse me. Ultraviolet light. Oh my God, I'm sorry. Ultraviolet light. This is usually linked to getting a tan. This type of radiation can be used to produce an essential vitamin called vitamin D, which is also essential for growth. It's essential for the cells needed to replace itself, or to divide and all those good stuff. To the cell the UV light has an ionization. It has an ionizing agent in it, which can pierce through the skin and go into the cell. And when it hits the DNA, it can cause the DNA to mutate or to start misbehaving, and from that it can lead to cancer. It can become cancerous. But there are also some good stuff, good things related to ultraviolet wave. They can help to sterilize water. For example, UV light can be used in sterilizing machines, food. It can help to preserve the food longer. It can even some equipment. It can help to cleanse things, sanitize things. Water can also be sterilized when exposed to UV light, as the light kills the bacteria in it. Police also use UV light to identify finger and shoe prints during forensic investigation. Some chemicals absorb UV light and display. Now, this is where the comparison comes. There's some chemicals absorb UV light and display visible light. This is seen in fluorescent bulbs, like in clubhouse, or also some of the bulbs, some of the galaxy bulbs or galaxy tools that we buy to help the baby sleep. They are also exuding, that is UV light exuding visible light. We can see different colors, purple, different colors coming out from that equipment. So we're going to be quick. We have the uses and hazard of X-rays in medical application. We're going now into X-rays. What are X-rays? X-rays are used to scan body images as well as spot any uh spot any hidden object. For example, in the airport, to detect people carrying prohibited weapons, prohibited equipment. In the hospitals, they are used to detect fractured bones. Patients with bone injury are usually asked to undergo X-rays, urinary tract conditions, mammography. This can all be spotted through X-rays. Exposure to X-rays causes ionization, which can increase the risk of developing cancer later. But the short-term side effects are very low. Exposure to high levels of X-ray radiation can have many effects, including vomiting, bleeding, fainting, hair loss, loss of skin or hair, etc. For example, when we have people that have cancer and they are exposed to so much radiation, so much X-rays, you can see some of the hair falling off and things like that, which is which can be linked to the side effects of X-rays. Okay, the benefits and risk of X-rays are weighed before it is recommended. X-rays are advisable to detect any bodily abnormality on time, which in turn helps with a better treatment. Okay, treatment options. So now we are looking at the biohazards of ultraviolet and infrared radiation. Ultraviolet radiation, like I said, can pierce through your skin, can hit your skin cells, can go through the DNA, and it can damage your skin. It can damage your skin cells. Okay, we said UVA are not that harmful, but can be UVB, UVC can be very harmful, right? And we see people putting on sun cream or suntan to, putting on tan creams and things like that to be able to protect their body from the sun, the violence of the sun. We also see people wearing the sunglasses to protect their eyes from the damage of the sun. Okay, from the damage. And then we look the photograph on the image on the right is an example of infrared radiation. Is a charcoal, very hot. It's exuding infrared radiation, exuding heat. Okay, but it can also burn a cloth. It can set something on fire. It can be hazardous as well. It can make that environment very hot, and you have to be careful with that. Effects of ultraviolet and effects and the effects of ultraviolet and infrared radiation. I'm putting a watch on my time. Can cause global warming, can damage the eye. It can cause things like cataract, glaucoma. It can cause skin cancer, like I just said. Okay, from UV and things like that. Causes it can cause global warming when there is so much. We have industries that are being warned by the government that they're emitting so much carbon in their thing production. Okay, so it's something to keep an eye on. Can damage the eye. For example, people that are doing welding jobs that are using so much light or infrared light. You say the company provide goggles or eye goggles for them to protect their eyes from that radiation, which is very important. So these are some of the um preventative measures that we can take to help protect our employees or protect ourselves from the damage of some of this radiation. Okay, so in conclusion, the world as we know it wouldn't be the same without the electromagnetic spectrum. You can listen to the radio and follow what's happening around the world in the comfort of your own home, which is amazing. Development of treatments for certain types of cancer using gamma rays, brilliant. And it even has the ability to keep our home warm during winter through infrared rays. All these waves have a positive impact on our lives. And although global warming is a concern, I believe that the EM waves, the electromagnetic waves, are having more positive impacts on the planet than negative. Thank you so much for listening to this presentation, and I hope you picked something from it. Thank you. So this presentation, we have done the explanation of principles and properties of types of electromagnetic waves, properties of microwaves and infrared radiation using selected example. We have looked at uses and hazards of X-rays. We have compared and contrasted the UV light and visible light, some applications of UV light and visible light, biohazard of ultraviolet and infrared radiation, and their main effects. We have looked at all this in this presentation. And lastly, we have our references. Thank you so much for watching, and God bless. I'm just going to end the recording.